We're still working with identities, and in this particular section we're talking about half-angle identities. This is the list of half-angle identities, and if you notice on the left-hand side of each one I have an angle divided by 2, so that's why it's referred to as a half-angle identity. Also notice that we only have half-angle identities, one each for cosine and sine, but there's 3 half-angle identities for tangent. So usually what we want to do there is we want to choose which is the simplest based on the information we have provided. So go ahead and click pause and copy down these half-angle identities on your formula note card or your formula sheet. Okay, so now that we have the half-angle identities down, we are going to sort through some problems similar to the ones that we've already worked with. We're going to find exact values, we're going to establish identities, we're going to simplify expressions. So the first ones I want us to get started with are tangent is 75 degrees. So I want to use that tangent right away. Now a couple of quick things to remember. This particular section we're working with half-angle identities, so I'm probably going to be using the half-angle. But remember, we also had other problems that we could have taken the tangent of 45 plus 30, and we could have used the tangent of the sum, and we have formulas for those as well and identities for those as well that we could use. So it doesn't matter which approach you take, as long as you show your work, you should get decimal equivalents. So on your calculator, if you're in degree mode, you can take the tangent of 75 degrees and get a decimal approximation. When we get done, you should take the decimal approximation for your answer and see if they're equivalent. It's a quick way to check, but again, you have to be able to show your work and find that exact answer. So to find the tangent of 75 degrees, it looks like we have 3 different options up here. So here I would need to just know cosine. I would need to know what quadrant I'm in, but that's not too difficult. Over here I would need to know sine and cosine, and same as the bottom, I would need to know cosine and sine. So I think for this one I'm going to go ahead and just use this first formula. And again, it doesn't matter which one we use. So if you chose to use a different one, that would be just fine. Now 75 degrees is in quadrant 1, so that means I'm going to choose the plus here. And again, that means quadrant 1. That's why we chose that. Okay, so using that formula, we have 1 minus the cosine of, well, I have a little bit of a problem here. It says to use the half-angle identity, and I don't really have that. I needed to figure out a over 2 first. So let's back up a little bit. We're still going to use that information that we have here. I need to write this as some angle divided by 2. So 150 divided by 2 is 75 degrees. Now when I choose my plus or minus, I choose it based on the original angle. So the original angle was 75 degrees, so I still know I'm positive because I'm in quadrant 1. So this formula that we would use then is 1 minus the cosine of 150, which is the standard angle that I know about from my unit circle, over 1 plus cosine of 150. Now 150 is in quadrant 2, so the cosine will be negative, and the reference angle for 150 is 30 degrees, so these will follow with the cosine of 30 degrees. So this is going to equal that positive again. It's an applied positive. 1 minus the cosine of 150 degrees is going to be square root of 3 over 2. 1 plus the cosine of 150 degrees is going to be the square root of 3 over 2. Now one thing I have not accounted for yet is, again, the cosine is negative in quadrant 2. So both of these should be negative in quadrant 2. Okay, so now we simplify. So this would be the square root of 1 plus square root of 3 over 2. I'm going to split the top and the bottom into 2 separate radicals, and 1 minus the square root of 3 over 2. Finding a common denominator, I'd have 2 plus root 3 over 2 all over 2 minus root 3 over 2. Okay, rewriting again. When you divide by a fraction, you're actually multiplying by the reciprocal. So I'd have 2 plus the square root of 3 over 2 times, and then I would flip this. This would be 2 over 2 minus root 3. So from here, I can see that the 2's would cancel. They're both radicals underneath the radical, so I can do this. And I'd be left with the square root of 2 plus root 3 over the square root of 2 minus root 3. Now I could try and rationalize that denominator. So let's see what happens if we do that. So I'll multiply top and bottom by 2 minus root 3. So from here, I'd end up with that radical multiplied by itself is 2 minus root 3. And in the top, what ends up happening is I have the square root of 2 plus root 3 times the square root of 2 minus root 3. I can combine that under one radical. Okay. So then I FOIL that out. I get my first outside, insides, and last. So my first terms, 2 times 2 is 4. My outside is negative 2 root 3. My inside is positive 2 root 3, so they cancel. And then my last would be in minus root 9, which is a minus 3. The denominator, I have 2 minus root 3. In the top, I have 4 minus 3 is 1. So that'd be the square root of 1 times over 2 minus root 3. Rationalize one more time. Sorry, that would be 2 plus root 3. So this is going to be left with 2 plus root 3 over 2 times 2 is 4. My outside and my inside terms cancel, and minus the square root of 9 equals 2 plus root 3 over 4 minus 3 is 1. So 2 plus root 3 over 1, which is just 2 plus root 3. Whew, that was a long one. I think I regret my choice of the formulas. Remember, we had 3 to choose from. I think I would have been better off choosing one of these other ones. I would have had the same equivalency, but maybe just a little bit less work. So you got to stick with these. If one doesn't look like it's going well, you could switch to one of the other options for tangent, and maybe you might have a little bit shorter problem, maybe a little bit easier problem as well. Okay, let's look at another one. Here we're going to be given a value for cosine. So here we're given the cosine of alpha is equal to 2/3, and we're also given that alpha is between 0 and pi over 2. And what we want to do is the exact value. An exact value means no decimal approximations of the cosine of alpha over 2. Okay, so let's go ahead and look at all of our formulas that we have to choose from. Okay, so it looks like the cosine of alpha over 2 is going to be this one right here. So the cosine of alpha over 2, or a over 2, however you want to write it, is equal to plus or minus 1 plus the cosine of alpha all over 2. Now we know which quadrant we're in. We're in quadrant 1. So I would choose cosine to be positive because I'm in quadrant 1. So cosine alpha over 2 is that positive value. That's an implied plus. Now this square root sign, I should be careful how I write that. That goes completely over the numerator and denominator. It's not just in the numerator. So this would be 1 plus the cosine of alpha. Oh wait, but they told us what the cosine of alpha was. It's right up here. It's 2/3. And this is over 2. So this would be 3 plus 2 over 3 after I find a common denominator all over 2. So this would be 5/3 divided by 2. But when we divide by 2, it's the same as multiplying by the reciprocal of 1 over 2. So this would be root 5/6. So this is root 5 over root 6. I'd rationalize that denominator, and I'd have the square root of 30 over 6. And that's the correct simplification for that. So we just need to know a little bit about what quadrant we're in, and then based on the quadrant, I can kind of work from there. Now we're working with layered fractions here, So make sure you remember how to find that common denominator. And again, when you divide by a fraction, you multiply by the reciprocal. And we're going to be doing that so much with all of these problems and all of these identities that it's an important skill, it's a crucial skill to have. Let's go ahead and look at another example. Here we're finding the exact value as well. We're finding the exact value of the sine of 15 degrees. Now, this says to use the half angle identity. And I'll show you what happens here if we don't use the half angle identity when we're done using the half angle identity. So we need to use the formula sine of a over 2 equals, and that's right up here, if I just follow right up here, sine of a over 2 equals plus or minus, I'm going to have to figure out which quadrant I'm in, 1 minus the cosine of a all over 2. Okay, so we have 15 degrees here. So if I want this to work, what divided by 2 would give me 15? And the answer is 30 degrees. So this would be plus or minus, but 15 degrees is in quadrant 1. Okay, so if this is in quadrant 1, this would be positive. Again, in quadrant 1. 1 minus the cosine of 30 degrees over 2. The cosine of 30 degrees is square root of 3 over 2, all over 2. And then when I simplify this, I'm finding a common denominator. I'm going to show this step a little bit extra. So this would be 2 over 2 minus root 3 over 2 all over 2. So this would simplify into 2 minus the square root of 3 over 2 all over 2. And that's all underneath the radical. So again, what we have here is 2 minus root 3 over 2 divided by 2 over 1, all underneath the radical. So 2 minus root 3 over 2 times 1/2. When you divide by a fraction, you multiply by the reciprocal. So I'm left with the square root of 2 minus root 3 over 4. And then I can separate this into two pieces. And the square root of 4 is 2. So I'm left with the square root of 2 minus root 3 all over 2. So this is our correct answer. Our decimal approximation, so this is exact. Our decimal approximation for this is 0.2588819. I could have also used a sum, or a difference. I could have done the sine of 45 degrees minus 30 degrees. And if I did that, I would get the answer of root 6 minus root 2 over 4. They don't look the same, but they're decimal equivalent the same. So you don't have to always just use the half angle identity or the difference. Either one would work here. You'd get the correct answer. But always look to your directions, because you can see that these answers look different, and so they're probably going to be grading you based on the way that they wanted you, or they suggested that you solve it. So be sure to read through those. Okay, so just like we've done before, let's go ahead and find another exact value. This one is going to be cosine. So let's go ahead and find the exact value of cosine pi over 12. Okay, so if you're not very good with radians, go ahead and convert this. You don't have to if you like to use the radians. So this would be 180 over pi. Okay, so the pi's would cancel, and then 12 goes into 180, 15 degrees. So this would be the cosine of 15 degrees. So if we're going to use our half angle, this would be the cosine of 30 degrees over 2. Now we have to go ahead and pop in those formulas. Let's see what we have to choose from. I think I shrunk them down a little small last time, so let's try and keep them a little bigger so I can read them. So this one we're using alpha, or a over 2. Now 15 degrees is in quadrant 1, so I know I'm going to use the plus here because I'm in quadrant 1. 1 plus the cosine of 30 degrees over 2. And again, I get that alpha or that a from here. Cosine of 30 degrees is the square root of 3 over 2 all over 2. Find that common denominator. That would be 2 over 2 plus the square root of 3 over 2 all over 2. So I'd have 2 plus root 3 over 2 divided by 2 over 1. And remember, whenever you divide by a fraction, you're actually multiplying by the reciprocal. So this would be 2 plus root 3 over 4. And of course the square root of 4 is 2. So this would be 2 plus root 3 all over 2. Now remember, for this particular problem, that radical sign is only under the numerator because I already took the square root in the denominator. Let's go ahead and look at one where we're working with tangent. Let's look at the tangent of 112.5 degrees. So in order to use our formulas, we need to know what divided by 2 is 112.5. So we just double 112.5 and we get 225 degrees, which is a multiple of a 45-degree angle. So I have three formulas that I could use. Let's just scroll back up here. I have three different formulas I could use for tangent right here, here, and here. And again, it doesn't matter. We can use whichever one we want. I think for this one, I'm going to just choose sine of A over 1 plus cosine of A. For no particular reason, I could have used any formula there. So this would be the sine of 225 all over 1 plus the cosine of 225. Now again, 225 is in quadrant 3. So the sign in quadrant 3 is negative square root of 2 over 2. And again, this is a value memorized from our unit circle. Cosine in quadrant 3 is also negative, so 1 minus the square root of 2 over 2. And then I just go ahead and simplify from here. So this would be negative square root of 2 over 2 divided by all of this, 1 minus the square root of 2 over 2. But I can't flip this yet, and the reason I can't flip it is it's not a single fraction. So this would be 2 over 2 minus root 2 over 2. And now I write it as a single fraction, 2 minus root 2 over 2. So negative square root of 2 over 2. Now I flip it. When you divide by a fraction, you multiply by the reciprocal. So the 2's flip up, and then you can see that they cancel. So this is equal to a negative square root of 2 over 2 minus root 2. Now we need to rationalize this denominator by multiplying by the conjugate. So this would be 2 plus root 2 over 2 plus root 2. So this is negative 2 root 2 minus 2. And that's by taking this value and distributing it. And then denominator I'll FOIL. First outside, insides last. So I'll have 4 outsides, insides multiplied together, cancel, minus the square root of 4, which is 2. So on the top I could pull out a 2 and I'd be left with a negative root 2 minus 1. In the bottom, 4 minus 2 is 2 and they cancel, and I'm left with negative 1 minus root 2 or negative root 2 minus 1. It doesn't matter how you'd write it. So you have to know your unit circle. You can see that it's going to come in handy. And you also need to be able to work with fractions. And remembering, when you divide by a fraction, you multiply by the reciprocal, but the reciprocal has to be a single fraction. So I think we've gotten the kind of the hang of writing those exact values. Let's go ahead and switch to a different type of a problem. So for this one, let's go ahead and find the exact value of the tangent of theta over 2 given sine of theta equals 3/5, and that we are between 0 degrees and 90 degrees. So I'm in quadrant 1, basically, that information means. Okay, so if I'm going to find tangent and I'm given sine, let's see what our options are here. So it looks like for tangent I need to either know cosine or sine and cosine. So we know sine, so let's go after one of these where we know sine and cosine. So I'm going to use this one right here. And again, it doesn't matter which one we choose to use, that's just the one I picked. Now, I need to know what cosine is. So what we know is the sine of theta equals 3/5. So if I want to figure out what cosine is, I can use right triangle trig, or I can use the fact that I have a Pythagorean identity that says sine squared of theta plus cosine squared of theta equals 1. So sine of 3/5, this would be 3/5 squared plus cosine squared equals 1. So it would be 9/25 plus cosine squared equals 1. Cosine squared is equal to 1 minus 9/25, which is 25 over 25 minus 9/25. So cosine squared of theta equals 16/25. Now what I'll do is I'll take the square root of both sides and I get cosine of theta equals plus or minus, the square root of 16 is 4, square root of 25 is 5. But remember, I am in quadrant 1 from up here, so I can just say the cosine of theta is 4/5. Now I already know that the sine of theta is 3/5, and that was given to me at the beginning of the problem. So now to find the tangent of theta over 2, that's going to be the sine of theta over 1 plus the cosine of theta. So the sine of theta is 3/5, 1 plus the cosine of theta. So in the denominator I need to find a common denominator, so this would be 5/5 plus 4/5. So this is going to be 3/5 divided by 9/5. And when you divide by a fraction, you multiply by the reciprocal. And it looks like from here, wait, there should be a 9 here. This should be 5/9, sorry. So the 5's will cancel, and I'm left with 3/9, which is 1/3. And I could have used the other formulas as well, and I would have come up with an equivalency to 1/3. So it doesn't matter which of the 3 formulas that we chose for tangent. You just have to go through, show your work, make sure you're choosing the correct quadrants, etc. Okay, so I think you kind of have the hang of that. I'd like to work with one where we're not in the first quadrant. So let's look at an example where we're not in the first quadrant. So let's go ahead and find beta over 2, tangent beta over 2. And for this problem, we'll be given tangent beta equals negative root 5 over 2. And I am in the quadrant that's between 270 degrees and 360 degrees. So this is basically Q4, quadrant 4. Okay, so if I'm going to use one of my tangents of beta over 2, I have 3 to choose from, remember. There's not one that just involves tangent. I have to know sine and cosine. I have to know some of those for some of these. So from here, from tangent beta equals root 5, negative root 5 over 2, I need to be able to find the cosine and the sine of beta. So the last one we used, sine squared plus cosine squared is 1. We could also use 1 plus tangent squared is secant squared. We could also use some right triangle trig. So we haven't done that in a while. So Sohcahtoa, so that tangent would be opposite over adjacent. Now remember, I'm in quadrant 4. So let's go ahead and put up our triangle. And if you want to drop this into quadrant 4, you can. I'm just going to put up the triangle though. And I'm just going to remember which quadrant I'm in. So here's beta. So opposite would be negative root 5. Adjacent would be 2. And then if I want to figure out the hypotenuse, that would be legs squared plus legs squared equals hypotenuse squared. So we'll call that c squared. So 4 plus 5 is c squared. 4 plus 5 is 9. c is equal to 3. So from here, what I can do then is I can find the cosine and the sine pretty easily, but I have to remember that I'm in quadrant 4. So the cosine of beta is adjacent over hypotenuse, and I'm in quadrant 4, so that will be positive. And the sine of beta is opposite, Sohcahtoa, opposite over hypotenuse, and I know it's going to be negative because I'm in quadrant 4. So remember, what we were asked to do, seems like a long time ago now, is to find the tangent of beta over 2. I have 3 formulas to choose from. I think I like to use, I'll use this one this time. I like to use one without that radical, and that just makes things a little bit easier. And also I don't have to choose between a positive and negative because the solutions pop out when I use one of these last 2 forms. So for the tangent of beta over 2, this would be 1 minus the cosine of beta all over the sine of beta. So cosine of beta is 2/3. Sine of beta is negative root 5 over 3. So this would be 3/3 minus 2/3 all over negative root 5/3. And again, you have to get used to flipping these fractions. So 3/3 minus 2/3 is 1/3 divided by a negative root 5 over 3. But remember, when you divide by a fraction, you multiply by the reciprocal. And I'm just going to keep that negative on top. And we'll see that these 3's cancel, so I'm left with a negative 1 over root 5. And of course we rationalize that denominator, so I have negative root 5 over 5. So we're really doing a lot of algebra for these problems, more than anything, I think. So hopefully you have some pretty sharp algebra skills. Now, sometimes when you're given a problem, there may be more than one way to solve. So given, in this case, that the cosine of 2x is equal to 3/5, and we're also given that we're in quadrant pi over 2 to pi, so that's quadrant 2 basically. We want the exact value of the cosine of x. Now when it says exact value, that means square roots, fractions, not decimals. You can use the calculator to check, but you can't use that for your final solution. So how do I figure out what the cosine of x is, given that cosine of 2x is 3/5? Well, I can think that we could use the formulas that we just learned here, the half-angle identities, but that transition is going to be a little bit tough. What I do remember, and again this should be on your sheet of formulas and identities, I remember that the cosine of 2a is equal to 2 cosine squared of a minus 1. So again, this is an identity looking on your sheet that you'll find, and I think it'd be a really easy one to use for this problem because I'm given 2a and I'm asked to find a. Now you could use a half-angle identity. There's many ways to work this, so if you have a different approach, that's fine. Just be sure to show all of your work. So the cosine of 2a, or 2x in this case, is 3/5, 2 cosine squared of a minus 1. So I'll add 1 to both sides. So 1 plus 3/5 would be 5/5 plus 3/5 is 8/5 equals 2 cosine squared of a. Divide by 2. Kind of running short of room here. So here I have 8/10 equals cosine squared of a. So that would be 4/5 equals cosine squared of a. I would go ahead and take the square root, so I'd end up with cosine of a equals plus or minus the square root of 4 is 2 over root 5. Now I need to figure out which quadrant I'm in. Remember, pi over 2 to pi is quadrant 2. In quadrant 2, cosine is negative. So I would be left with negative 2 over root 5. Multiply top and bottom by root 5 to rationalize. So this is negative 2 square roots of 5 over 5. So that would be the exact value of cosine of x, given that the cosine of 2x is 3/5. So when we're working these problems, we've been working them kind of forward, meaning I'm given some information about the cosine and then asked to work backward. But I could be given an expression that's simplified into one of the right-hand side of those equations, and then from here I might be asked to figure out exactly what this is. So what would this be? The cosine of, the tangent of, the sine of. Well, if we go ahead and pop our formulas in, this looks very familiar. This looks like 1 plus cosine. This looks like the cosine of alpha over 2, or a over 2. So the formula I'm going to use here is the cosine of a over 2 is equal to positive, because that's up here is positive, square root 1 plus the cosine of 74 degrees all over 2. So this 74 comes right here, 74 degrees over 2, and half of 74, as it turns out, is 37. So this is the cosine of 37 degrees. That's what this expression is equal to. So this one, I was given the right-hand side, and I kind of had to work backward to the left-hand side. And you'll run into quite a few of these types of problems. But again, don't let it throw you. We just have to be able to work with these both directions, not just left to right, but from right to left. Now the final type of problem that we'll see here is verifying an identity. So this one, let's go ahead and verify the identity that tangent squared of theta over 2 is equal to secant of theta minus 1. And now that minus 1 is not inside the argument of the secant function. Always put parentheses around the argument of your trig function so it's never ambiguous. So this equals secant theta minus 1 over secant theta plus 1. Now when we're establishing an identity, usually we like to start with the more difficult side. I think that both of them look fairly difficult, but that tangent squared kind of makes me think that I want to try and work with that one. So tangent squared theta over 2. Okay, well, let's go ahead and pop in our formulas again. So tangent squared theta over 2. I'm going to put them right up here. So I think that what we could use here, I'm looking at this and I'm thinking that secant relates to cosine, so I think I want to use this one right here because they both have cosine. So this would be plus or minus square root 1 minus the cosine of theta over 1 plus the cosine of theta. So that's how we can get started here. So what we can do next is square this, because this is tangent squared. This is just tangent. And so now I need to square that. So I'm left with 1 plus the cosine of theta over 1 minus the cosine of theta. Now remember our reciprocal identity, cosine of theta is 1 over secant theta. And then I could find a common denominator here. This would be secant theta over secant theta plus 1 over secant theta. This would be secant theta over secant theta minus 1 over secant theta. So this would be secant theta plus 1 all over secant theta all over secant theta minus 1 all over secant theta. Now remember, when you divide by a fraction, you're actually multiplying by the reciprocal. So this would be secant theta. Now remember, put parentheses around the argument of your trig functions. Otherwise we won't know is that plus 1 part of the argument or not. And this is divided by secant theta minus 1 over secant theta. When you divide by a fraction, you're multiplying by the reciprocal. So this secant theta would pop up top. Secant theta minus 1. So now these cancel, and I'm left with secant of theta plus 1 over secant of theta minus 1. And again, you have to put parentheses around the arguments of your trig function. If you write this, sorry, I don't know what the argument is. Is the argument theta or is the argument theta plus 1? So do not write them like this. Always put parentheses around the arguments to make it really easy to look at, because that makes it easy to give you points when you're going through for partial credit. So these are all examples of different half-angle identity applications. If you have any questions, please let me know. I'm happy to help.